So good afternoon, everyone. My name is Kelsey Jones, and I'm a Senior Program Manager with the National Association of State Energy Officials, or NASEO. And I'm looking forward to a great webinar today on innovative microgrid project designs. This webinar is part of an educational series hosted through the NASEO-NARUC Microgrid State Working Group, and will provide information on two unique projects, a mobile microgrid and a clean hydrogen-powered microgrid that may be of interest to state energy offices and state utility regulators. I will be joined in moderating this webinar by Wilma Curry, a Senior Technical Program Officer with NARUC. And just a few quick logistics before we get started. All attendees are off screen and muted, so please add any questions for the speakers to the chat or Q&A box, and we'll address those after the presentation. We will also be recording this webinar and distributing the slides to all the registrants next week. And finally, I just wanted to thank the U.S. Department of Energy's Office of Electricity for their support of this webinar and the larger Microgrid State Working Group effort. So now it is my pleasure to introduce our three great speakers today. We have Shelley Peterson, a program manager with the Iowa Economic Development Authority and State Energy Office, Ann Kimber, the director of the Electric Power Research Center at Iowa State University, and Armando Infonson, director of business development with SoCalGas. Now over to you, Shelley, to get things started.
Thanks, Kelsey. And thanks everybody for joining us and giving us an opportunity to talk about a project that we actually started several years ago. We call it the Mobile Microgrid Project. It's kind of been shortened to the CRATE over the years, just kind of rolls off your tongue. And I am with the State Energy Office here in Iowa, and we partnered with Iowa State University on this project. Next slide, please. We actually had two financial awards to the university to sponsor this project. One was through our formula dollars, and one through SEP-ARA Legacy Grant. And we've been working on this project, as I mentioned, for several years. Kind of interest to state energy offices. We did make an amendment to the project. As you know, as the end of your budget year comes, you may have funds that you need to expend. And this was a project that, the scope could easily grow, and we were able to give it a little bit of extra funds in 2022. Another interesting thing to note, we often work with our state universities. It's a simple procurement pathway for us. And we've had a long-standing relationship with them, which I think really leads to the success of some of the projects that we do. There were other partners involved in this project, and Ann will speak more to their role. But our office did kind of help marry these partners. For instance, PowerFilm is an Iowa manufacturer of the thin film solar. And we did request that as this unit was put together, that we could feature as many Iowa businesses as possible. Next slide, please. So the scope was fairly large. I'm not going to read all these, and we'll kind of show you some visuals so you can see what it ended up looking like. But we kind of just kept adding two things that we thought would be useful as this project evolved. Next slide, please. But, the real takeaway for us was sometimes you need more than a report. And this particular one, we had a lot of public engagement. The various utilities in the state were highly involved, which is tricky. Iowa actually has 181 different electric utility providers. By the time you get the investor owns, the municipals, and the rural electric cooperatives. So we've got a really big audience that we need to educate. This particular photo was the crate came to my office building one day, and it powered food trucks. And everybody in the building came out, could take a look at it and get a lunch. And the National Guard members did the assembly and disassembly that day. Another important group we were able to reach was emergency managers. I'm really excited that now our state Homeland Security and Emergency Management Division, they use the word microgrid in their conversations. So that's been a real win for us as well. Next slide. To share a few quick takeaways, the number of spin-off opportunities that resulted from this project, we couldn't even imagine. We've been introduced to Sandia National Lab. We've got utilities doing large-scale fixed battery projects. And we've got a spin-off project that's working with these systems at wastewater lagoons where electrical service is an issue. One thing, a question to ask is, why did we pick this project? Our office tries to align anything we fund with our state energy plan. And this particular project hit several of those key things that we're looking for. It's innovative. There's some training, education awareness, and just that grid technology system. Publicizing the effort, always a very important part. These are kind of the standard things for any project that we work on. Next slide, please. And then lastly, creating public-private partnerships is important, especially in my office where we're housed at the Economic Development Authority. So this has been a really successful project that's garnered the attention of people beyond just the energy team in our building. One of the lessons learned was, this project was so visible, and we really benefited from making power visible to the people. It's helping us learn how to tell the microgrid story to various audiences. And we're able to continue to build upon that success and keep up the dialogue. And with that, Anne's going to share a little bit more about what the project looked like and how it evolved.
Thank you. Can you all hear me? Yep. Okay. So first, I want to thank you all for inviting me to be part of this presentation today. And I especially want to thank Shelley for her constant support throughout the various phases of this project. That universities usually simulate and study things and write research papers. It's kind of rare for a university to build and take a project like this on the road. But this project was really important for us because we had to prove out the technology. We had to be open to public interest and a lot of tough love and questions about the project. The tough love came from the Iowa Army National Guard, and it improved this project significantly. But the other reason it was so important to take this project on the road, as we have been doing, is that it sparked people's imagination. As you probably know, it's kind of rare for the public to be able to drive up to a power system and be able to learn about it, have a tour, see solar panels up close, see battery inverters up close, think about how these systems work and the challenges. And I think the most important things that came out of this project was the public engagement here. I remember one Sunday afternoon, I was checking on the crate, as I often did, and this dad and his 8-year-old son drove up in this giant pickup truck, hopped out of the truck. They didn't even stop the truck. They just ran out of the truck and they ran towards me. And I thought, what's going on? And the dad was saying, tell him, tell this kid what this is. And it turns out they were super excited and the kid wanted to become an engineer. And I thought, okay, my work is done here. So I think that that's one of the big outcomes, is you're providing an up close view of what a microgrid is to people who will think about it in their own ways and come up with their own use cases. So I want to thank the people who worked on this project. You can see them all there at the right, and there's my website here, and this first slide just has some technical details about what the crate is. It's not a big system. It's 14 kilowatts of solar and up to 78 hours, kilowatt hours of battery storage and other things like that. You can go to the next slide. So the background is that this microgrid evolved from an earlier microgrid that was installed in Puerto Rico after Hurricane Maria, and it was installed at a school in the mountains that had a lot of power outages. And it's been operating there since August of 2018. And the person who built that microgrid ended up being the person who built our microgrid, and his name is Dolph Ivener, and he's a farmer from Sioux City, Iowa. And then we worked with all these other folks too. The Iowa Army National Guard gave us really, really important feedback on the use cases and their requirements for how such a microgrid could be deployed in a disaster. And then we had many Iowa State faculty and students lending their expertise. And finally, and maybe even more important, is that we had a committee of utilities and the National Guard. So we had investor-owned utilities and 2 municipal utilities, as well as the National Guard. And we were meeting with them every month to talk about progress we'd made. And we found as we were talking to them that they were also designing their own microgrids. So sometimes we were ahead of them a little bit, and sometimes they were ahead of us. And we were really trading technical information back and forth and really helping each other. And that was just wonderful. So there were these different phases of the project. The first one was we had to deliver a mobile microgrid to the National Guard requirements. We also developed plans for a second crate that would be used for humans as an office or a mobile control center or something like that. And then the second phase, as Shelley explained, we had to improve everything and bring back input from Iowa Department of Homeland Security and county emergency managers. Okay, you can go to the next slide. Okay, so this is just showing that we tried to build this microgrid and write the instructions for it so that teams of what you might call unsophisticated labor can take this microgrid apart and put it back together. So what you're seeing here is what Shelley alluded to. We had a team of National Guards folks take the microgrid apart, move it to their Camp Dodge training facility in Iowa, and put it back up together again. And as they were doing that, we were checking what they were doing against our instructions to make sure that we had written things in a way that people could understand. And that really helped us. And they seem to really enjoy it as well. On the upper right, that kind of interior picture, you can see in the very back corner, Dolph Ivener, he was there. So he's our first microgrid guy. And we're loading everything into the microgrid. So it holds all the solar panels, all the racking, all the equipment is inside the crate. And you can see the inverter and some of the power panels there. So that's what we did. You can go to the next slide. Okay, so why do this? And I put some kind of funny pictures here. So the reason we did it, the reason we wanted to do it, is that we knew that the technology would work because we'd simulated it. We'd written research papers about it. But demonstrating that these kinds of technologies, these kinds of renewable and energy storage projects can work for community is something new. So we wanted to prove that we could build it and we could make it modular. We had this leadership and funding from IEDA that made it easy for us to do this. And we had a lot of passion among the team. And that's the reason I put the 2 upper pictures up. Like the typical Friday night at the crate, like we were just out there all the time, working on this, trying to fix it, make it better, even at night, scraping the snow off it in the middle of the winter. That was a picture that was taken by the City of Ames security camera. They caught me. So we had that. We had real dedication to this project, and we could see that it could lead to bigger applications. What was challenging to us was the challenge from the National Guard that made us design this to include not only single-phase power, but also 3-phase power and a diesel generator to power what they felt were the most important use cases. And when I tell people that we had to include a diesel generator that would seamlessly interconnect with all these other power sources, they say things like, ooh, like, oh, that's challenging, because that's not the normal microgrid, at least the normal small microgrid. But I have to say that during the course of this project, the public and the state agency interest increased, because right in the middle of this, right when we were testing it out, we had the August 10th, 2020 derecho, and the city of Ames lost power for days, and Cedar Rapids, Iowa lost power for longer than that. And suddenly we were using our microgrid for power, for cooking, for charging batteries for refrigerators, for charging somebody's electric car. And I felt like after that, the whole conversation changed. So go ahead to the next slide. Okay, so here's the idea. The idea is that mobile microgrids, and this is not even a new idea now, can serve as grid resilience assets. And this list of different kinds of use cases was given to us from the National Guard, for example, mobile water treatment and distribution pumping. It was also given to us by utilities and by county emergency managers. So can you power a gas station? Can you power critical local community shelters? And what are those? Turns out they're not schools. They might actually be churches. How do you do that? How do you provide critical power for a grocery store so the grocery store doesn't have to dump out its entire stock of milk, for example? How can you use a mobile microgrid like this to charge battery packs that you can take to people so that they can stay in their homes and not have to go to a shelter? To the county emergency managers, that's a really important feature of trying to keep the public safe and stable. So these were the kinds of challenges for the use cases for this sizing and designing these microgrid systems. And then the National Guard said, oh, by the way, your microgrid is too big. We want it to be smaller. It should go on a pallet or in a bucket, and we should be able to take 6 of them out and have them to be completely identical, and they will communicate with each other as daisy-chained plug-and-play systems. And that's where the research comes in, because that is not easy to do. But you're basically saying to somebody who may have no experience with these systems, go into that warehouse and get me 4 of those and connect them, and we'll have this much power, and it will be foolproof. And that's a difficult thing to do. So we're still working on that. We've started working on that. So anyway, the idea is to deliver these microgrids fully charged. There's immediate power for the utilities and a community resource. Okay, you can go to the next slide. So then this is where working at a university is so great, because I have lots of research collaborations with different kinds of utilities, and the utilities have been kind enough to provide use cases, load profiles for different kinds of critical loads. And I'm not going to go into details about how you would size a microgrid for each one of these things. But what I want to show you is that all customers, and anybody who, I mean, you guys all know this already, all customers are definitely not alike. Care facilities can be big or small. Cell towers, there's a little more consistency there. So what you're looking at is the demand on the peak summer day of the year in Iowa. This is real utility data. Gas stations can be very different depending on whether you're powering the pizza oven and beer cooler, or whether it's just an unstaffed gas station that only sells gas, which is a complete, much easier load to serve. Or maybe you're powering a communications hub. So all these kinds of features go into play. And I learned quite a bit about gas stations in the course of this project. And that is that they're all on one circuit. So you can't say, I'm just going to power the critical loads on the pumps and the computer to pay for the gas. I have to also power all the other coolers and everything as well. It would be really much nicer if we could separate those circuits out, but that's another project. So we're continuing to use load profile data like this. We have quite a lot of it because the utilities have been very kind to provide it. So we can say, okay, for these 7 critical loads, to power these 7, this is what the system will look like. And part of the reason that it's easier now to do that is that we can use tools that have been developed by NREL, like Reopt, like Homer, and like this new one, Hybrid Optimization and Performance Platform, the HOP tool, which is we're using it right now with a utility in Iowa to size battery and solar and distributed wind, which is pretty cool. So you can go to the next slide. Okay, so the outcomes of the mobile microgrid. So we have been using it to power an off-grid wastewater treatment process. We have great data. How did the microgrid perform through a winter? Right now, we're actually turning it into an on-grid connected microgrid to serve a swine barn at the ag student farm at Iowa State. I'm really, really excited about this because it means we're going to be teaching ag students about renewable and energy storage in microgrids. That's a whole different audience from us. We designed a sister microgrid to power off-grid construction trailers in Arizona that were being used to build a very large solar array. And we have a grant from the National Science Foundation to basically take the microgrid on the road for public education and to survey public interest. We have new projects as well. We're designing a new plug and play modular set of pallet-based microgrids to meet different sizes of loads. That's part of a new Iowa Energy Center project, again, for wastewater treatment. And we also used our IEDA funds to build and prove out that we could do it to plug and play daisy-chained pallet-sized microgrids. And so you see kind of this little rendering on the left here. That's what it looks like kind of from the top. There's a photograph of this pallet-based microgrid under the power film solar tent. It's about 4 foot on a side, and it's a little higher than that, than 4 feet, but it's very maneuverable. You can pick it up with a forklift or possibly drop it out of a helicopter, not that one, but we are designing our new ones to be dropped out of a helicopter. And to the lower right, here's a use case. It's a kids' carnival, and the pallet microgrid is powering a bouncy house for little kids. And you might say, the bouncy house is not a critical load, Anne. But I would argue that providing microgrids for these kinds of applications is also important because they're quiet, they're pollutant free, at least right there at the site. And they bring a whole bunch of different conversations into being with engineers and people who want these portable sources of power in possibly a cleaner way. So I'm really excited that we were able to do that. And that kind of led from these many discussions with all kinds of people. We would never have taken a microgrid to a kids' carnival if it hadn't been from previous discussions with the public. So I think I have a couple more slides if you can go on to the next 2. Okay, other things that have come out of the microgrid project, we were able to submit a successful FEMA BRIC scoping application. I'm really, really, really excited about this. And that came about because county emergency managers wanted a tour of the microgrid. That led to really good conversations. We've developed collaborations with national labs, including Idaho National Labs, Sandia, Pacific Northwest National Labs, on microgrids for different resilience use cases and on microgrid training. And you guys from NARUC and NASEO were part of some of those webinars, and I'm really grateful. There's a new set of webinars, the link is here, especially for people who are looking at FEMA projects. So we're using the FEMA email list for these webinars. So that's very exciting. And we have had continuing ISU senior engineering design teams working on this microgrid for several years now. So it's a continuing source of projects about communications, data analysis, performance. It's a great tool for undergraduate education as well. And we even got a grant from EPRI to help with that. So next slide, please. This is just an overview of the FEMA BRIC grant that we started very late last December. We have 2 years to develop a computational tool to site and size local energy resources to strengthen the FEMA defined energy lifeline for Story County. That's 13 communities in Story County I'm going to be doing this for. And the idea is that we demonstrate we do the right combination of technologies to demonstrate a FEMA benefit cost ratio greater than 1, and we can actually get FEMA funding to build some of these new kinds of systems. And that is a direct outcome of this mobile microgrid project. So next slide, and this is my last slide. All right, so during the course of this 4-year project, things have evolved. We have upgrades to the IEEE 1541 and California Rule 21 standards. We have this brand new tactical microgrid military standard for microgrids released in March 2023. We found out about that because of our relationship with the Iowa Army National Guard. There are new technologies, the Schweitzer microgrid microgrid controller, and there are microgrid ready generators running on hybrid fuels, including hydrogen. We're learning about the importance of plug and play operation. Utilities are now building microgrids and investing energy storage with microgrids. There's more technology, commercial options that are available now. We have FERC Order 2022 for using distributed resources that could include microgrids in markets. We were able to get critical load mapping resources through NREL assistance. And we have the really great microgrid resources that I refer people to through the work of NARUC and NASEO. And I'm so grateful for all of that. So that's my last slide. And thanks for your attention.
Great. Well, good morning, good afternoon, everyone. Thanks for the invitation to be in this panel. Really appreciate the opportunity to share our project that we developed here in California. As it was mentioned earlier, my name is Armando Infanzon. I'm the Director of Business Development for SoCalGas. SoCalGas is the largest natural gas distribution company in the country. We deliver about 5% of the natural gas in the country to 22 million customers. We operate in a very extensive service territory, about 24,000 square miles, and we operate a system of over 100,000 miles of pipeline, both transmission and distribution level. Next slide, please. Our mission at SoCalGas is to build the cleanest, safest, and most innovative company. Over the last couple of years, we published our sustainability strategy that we focus on supporting a net zero objective, not only for our operations, but also for the energy that we deliver. And we committed to our Scope 1, Scope 2, and Scope 3 emissions. But here in California, there are other aspects related to achieve decarbonization efforts, state objectives to achieve net zero across different sectors. And also, how can we provide more energy reliable, in fact, of all these different aspects. So this idea of the hydrogen innovation experience was developed to address those two primary and critical factors of decarbonization and achieving energy resiliency and reliability, contributing to the air quality of our service territory, as well as to provide a means for our extensive workforce to transition to clean energy systems. And also support different electrification efforts by the increasing integration of the electric and the gas systems, and develop this concept of microgrid for our communities. So that was kind of the premise around this idea. Next slide, please. So in everything starting in 2010, how we developed this concept of the hydrogen innovation experience. The project is located in the city of Downey at our Energy Resource Center. We have a great support for the city of Downey. We engage with different stakeholders like the fire department as we bring in these new technologies to our communities, right? So we want to make sure that we we engage with all the proper stakeholders to bring this type of new system to our communities. So the Hydrogen Innovation Experience showcase how hydrogen can play a role in the decarbonization as well as the electrification and increasing number of renewables being deployed throughout our state. The project includes two main components, includes the clean renewable hydrogen microgrid and a hydrogen home, and I will talk to both of them. Next slide, please. So in terms of the clean renewable hydrogen microgrid, this is a large-scale demonstration. That is a fully island system from the grid and provides reliability to the existing facility. Any excess power that is not being utilized as part of these demonstrations fits into the Energy Resource Center. But the microgrid showcase how clean renewable hydrogen, in this case, green hydrogen, can be produced to provide this type of reliability. So we have two sources of electricity. We have a 65 kV carport array, as well as 7 kilowatts of rooftop solar. These 72 kilowatts of electricity are fed into a battery. We have a 288 kilowatt hour, 60 kW discharge. So that gives us about 4.8 hours of constant flow of electricity. That electricity is utilized to inject it into an electrolyzer through a electrolysis process. We take water from the city, we run it through a purification process through an ionizer, and with the electricity and water, we're able to split hydrogen and oxygen. So we capture the hydrogen, comes at 437 psi from the electrolyzer. The hydrogen goes into a storage tank. We have 10 kilograms of storage. Electrolyzer has a capacity to produce 21 kilograms per day. Oxygen is released to the atmosphere on a safe manner. So the hydrogen, then it goes through different flows. The first one is hydrogen is currently blended through a blending skid up to 20% with natural gas. That later is being utilized by the hydrogen home. We also have a 4 kilowatt fuel cell. That's an 100% hydrogen fuel cell. So hydrogen is being fed to the fuel cell to provide extra reliability, to provide electricity all hours to the system. And then later we have a hub room. The hub room is kind of the brains of the system. It has all the power aspects, all the power equipment, controls, as well as a microgrid controller to be able to operate the microgrid as a complete entity. Like I say, this is fully island, so it operates 24/7 off the grid, and any excess is being utilized for our energy needs at the Innovation Resource Center. Next slide, please. We did some analysis in order to assess the reliability, right? One of the important aspects of microgrid across the different sizes and denominations. We have a great presentation earlier about mobile microgrid and some stationary microgrids. In this case, for our demonstration, is a scale that can serve about 100 homes during an outage, and this is during a summer outage in which you have solar. So this system can serve those 100 homes to provide critical load during this outage that provides basic needs to the homes to to write a potential outage like a refrigerator, basic ventilation, communication equipment, and some of the required appliances that will be needed during those outage. Next slide, please. Like I say, the second component was the hydrogen home. Very excited about this. So the microgrid is providing a blend product up to 20% of hydrogen today. We want to make sure that we do this in a safe and reliable perspective. Right now, we have 6 appliances, 4 of them indoor, 2 outdoor. So we have a tankless water heater, a stove, a fireplace, and a dryer all inside, running on up to 20%. These are off-the-shelf appliances that you can get at any store today. The tankless water heater today, commercially available, can take up to 30%, but we run it up to 20 for now. We also have 2 appliances outside, a barbecue and a fireplace. Sustainability is a critical aspect of all the projects that we do at SoCalGas. So this is a modular home that was developed with a local facility about 50 miles from the project location. This is a modular home. So we bring this home in 6 pieces. So we partner with Toyota and Hyundai to move these 6 pieces of the home with hydrogen trucks. So we want to make sure that the full project was that we capture all the sustainability aspects as possible. And that was a great partnership. This modular home was developed in about 8 hours on site. It get us to about 95% completion, and then we complete the rest. We're targeting to achieve a LEED Platinum certification for this home. As well, we designed this facility with the high-performing grid building design. And we also put a sustainable landscape. The home also have a water management system that capture rainwater as well as great water to be able to utilize for the landscape on site. We were receiving an award in 2021 by Fast Company as one of the world-changing ideas for this project. So very proud of that recognition. Next one, please. So it has been pointed out across this workshop, there are a lot of benefits of microgrids, right? The environmental benefits by bringing clean technology to reduce emissions and improve the air quality, as well as to embrace the increasing levels of renewables to really help with the decarbonization efforts across the country, states, and locally. Another key aspect of microgrids that this can be scalable, right? The microgrids can be designed with a purpose to either serve a community, serve a local need, and also remote needs or some different levels of configurations. So that's the beauty of microgrids. And finally, it adds a lot of resiliency and reliability, right? Microgrids provide that reliability when you experience an outage from the system or you're in a remote area. And here in California, we continue experiencing different power outages for different reasons. We have the PSPS related to our wildfires, but there are other events in natural disasters or other events that require increasing that reliability to continue serving our customers and providing clean energy solutions across the spectrum. So that's what I have for today, and happy to entertain any questions.
Thank you so much, Armando, Shelley, and Anne. These were such fascinating presentations on 2 really innovative projects. And so I'm going to turn things over to my colleague, Will, to guide us through our Q&A portion. So please continue to add your questions to the Q&A box. It looks like we already have quite a few, but We have plenty of time for question and discussion. Will?
Thanks, Kelsey. And yes, as Kelsey said, if you want to keep adding any questions you have to the Q&A queue, I'll try and get through as many of them as possible. I know we did receive at least a couple of questions about a specific webpage for the mobile microgrid project. And I'm going to ask my colleague Kira to drop a few links in the chat that are mostly press releases. Ann and Shelley, I don't think there is a specific page for mobile microgrid updates, but I'll let you maybe address that first.
Well, it's on me. I will make a mobile microgrid update website. It's a good idea. We have a lot of resources for both phases of the project. We developed very, very detailed instruction manuals, like how to operate your microgrid. I'd be happy to share those. I'm going to take all the passwords out, but I'd be happy to share those with you. I have spec sheets for all the components, and I have final reports, and we also wrote a white paper. Those should be on a microgrid website, but I'm happy to provide those to you. I guess I would send those to you, Will, and then you can disseminate those. Okay.
Absolutely, we can make sure those are sent out to the group here. I think, you know, the points you were making about the educational opportunities around the mobile microgrid project, particularly the portable bouncy house, I think is a really great conversation starter. I wonder if you could maybe touch on additional opportunities or use cases that you might be exploring for mobile microgrids in the state. You know, what kind of partnerships are you really looking to develop as conversation starters or otherwise?
Well, okay, so there's a question in the chat also that I want to make sure I don't miss. There was a question about the regulatory construct, like how does a mobile microgrid like this figure into somebody's rate base? And in Iowa, I don't have a good answer for this, but it's something that I worry about. But with the use cases, for example, Iowa has a huge bicycle race that takes place the last week in July every year. And apparently this year there's going to be a lot of e-bikes, and they're going to need to find a place to charge their e-bikes, like 10,000 e-bikes. Well, my mobile microgrid is not going to charge that. But in an ideal scenario, there would be mobile microgrids or mobile battery storage units parked at various places on the route so that there could be rapid charging. That would be a great educational opportunity. I might be able to, still hoping I can put mine somewhere, but farmers markets. You know, a lot of people go to farmers markets, hearing the diesel engines running the food trucks. It's stinky, it's loud, it's not fun. That's a natural place to do mobile microgrids, and it can really lower costs for the people operating those food trucks. We did that at Shelley's offices, and it worked really well. So that's one thing. Mobile microgrids at state parks for people riding trails on their e-bikes from one park to another park. Great opportunity to educate the public about these kinds of systems. Honestly, I would like to be able to use a mobile microgrid to talk about the difference between demand and energy. Like, this microgrid can last for this many hours at this peak, but if you lowered your peak by this much, it could last for this many hours. I think there's such a huge need for energy literacy, and I don't know, that's a mission that we can do forever. Things like that.
I think in a related note, we did receive a question from Jennifer Calais in the chat that says, has there been any discussion of integrating the microgrid concept with a battery electric vehicle as the storage component, such as a pickup or a public works truck?
Yes, so the way this microgrid works is that it sees the grid. Its grid is its diesel generator, but its grid could be a Ford F-150 Lightning. So yes, it's definitely, and we have a level 2 car charger on the side of the crate. So we have done some car charging, which has been very interesting, because then we've been able to look at charging profiles and how they integrate with the crate operation. So yeah.
Thank you. Switching over, Armando, we've received a couple of questions in the chat. I think I'll start with Mike Hornsby asks, do you produce hydrogen only to avoid solar curtailment?
Yeah, no, well, I think on the educational, I think is one of the key components for these demonstrations, right? To really educate on energy consumption as well of different alternatives to bring this reliability, right? So education is a key component of any demonstration. That's a key component for our project, right? So really, we're trying to demonstrate and educate to different stakeholders, right, across the different spectrums, from kids at school, STEAM members, officials, the community in general. For our projects, the two components, right? How the role of microgrids, how microgrids operate, right? And what are the different benefits microgrids can bring to your community, but also to demonstrate and educate how hydrogen is being produced, right? There's a lot of buzz on hydrogen and different attention across the country and the world on hydrogen, right? And the role that they can play, for example, in our case, in this microgrid, right? But seeing on a tangible live demonstration how hydrogen is a very strong educational piece to really showcase, right? So for this project, we view more all these components as an integrated system, that all of them working together to provide the different need that is required in different times of the day or the night or the situation, right? So sometimes solar will have a purpose, sometimes hydrogen will have a purpose, depending on what is the different modality of that operation of the microgrid, right? So we don't view it as an alternative to solar. We view it as both pieces working together to provide a clean energy and reliable source to customers and communities.
Let me also ask a follow-up. Tom Stanton in the chat has asked if you would describe how your system serves critical loads in 100 homes during outages. How much is that automatic and pre-programmed versus requiring individual attention each time there is an outage?
Yeah, so the microgrids have these microgrid controllers that kind of brain to operate the systems, right? So if there's a microgrid in an event of an outage, we activate to operate in that islanded mode and serve that critical load, right? In this case, we only have one home because we're doing a demonstration, so we couldn't build all the homes, right? But we did an analysis, and the way that we concluded is that based on the resources that we have on a solar day, which in California, that's when we experience the most outages due to different situations on the system, either for high levels of demand or wildfires. So there's solar during those days. So we assume solar resource be available because it's a sunny day. And the critical of what they find on the size of the home that we have, which is about 2,000 square meter, and providing the basic needs under a kind of critical load definition, right? What are the minimal electric needs for that home to ride that outage, right? Based on the solar, the battery, and the hydrogen that we have in the system, putting all this in an equation, we can serve 100 homes for a 24-hour outage.
Great, thank you. Shelley, I might ask you the next question. We did sort of, we received kind of an exploratory question in the chat that said, would participating states like to see a directory of all the microgrid in a box producers from around the world? And I'm wondering if that's something that maybe you could speak to, as if you find that would be helpful and interesting. And anyone else can respond in the chat too.
As a state, we don't really send people brand name type documents. I guess if there was a compilation that included everybody who wanted to be on there, you know, then that would be information that we could potentially pass along. So, you know, I know I've seen there's units commercially available and seen some really good webinars. So I know there's some out there. But I guess we would have to make sure a list was comprehensive so that we weren't leaning one way or another.
Yeah, and then let me ask, we received another technical question. Am I correct in understanding that the Iowa facility was custom built for you? And if so, why did DoD UPI not work with any of the pre-existing microgrid in a box providers who are already building and selling these kind of systems on wheels around the world?
On our end, you know, we first had this idea over 5 years ago. So I'm not sure there were as many, you know, there may have been products on the market, but, you know, not readily in use. So we started from the ground up. And since it was meant to be an educational project, I think it was important that we be able to take it apart, put it back together. I know Anne's team actually used different batteries at different times, and you know, could assess the ability to use a certain brand name of battery versus another, and then how the controls were influenced by that.
Yeah.
I don't think we could have done any of that if they hadn't started, you know, from the ground up.
Thank you. Armando, we also received a question in the chat. The first is, how are the critical loads defined and determined? And the follow-up to that is, how should we think about balancing the prioritization around the need for precious water sources to serve as an H2 source versus, for example, the need for drinking water and other environmental reasons?
Right. Thank you for those questions. Right. So the critical load would use public information about load in California for a home like that size, and we identify those different by the appliance, and that's how we quantify the critical load. Right. That's kind of standard definition in the market, like on an outage, what it will be the critical load for a residential customer. Right. In terms of water, I think that's a great question. Water, like everybody knows, is a big challenge. I think the potential for hydrogen really merits exploring the challenge of water resources, right? I think for this project, we use it small quantities, very small quantities from water from the city. It's still water that we need to do some minor treatment to put it in the electrolyzer. Electrolyzers need a certain level of purity in the water to be able to run through this technology. A large scale, when we think about water, we look into resources of water that can have a second life cycle. For example, producing hydrogen large scale, utilizing reclaim or recycle water, right? And tapping those resources instead of going to oceans of wells. How can you give another second life for that water that already provided one purpose, have a second purpose, take that water, treat it, and produce green hydrogen, right? So that's kind of the perspective, long term for hydrogen production.
Thank you. I think that's really an interesting response. Shifting gears, Anne, I wonder, we received a question, are the mobile microgrids also used under blue sky conditions, which I think maybe a children's bouncy house is as blue sky a condition as you can get, but I wonder if you could address that in a little more detail and perhaps also address what an Energy Lifeline GIS is.
Okay, I think I'm probably Energy Lifeline is separate from GIS, so I apologize if I confuse that. So Energy Lifeline is, so if you look up FEMA BRIC, BRIC Lifeline, you'll find that they define lifelines as it's a set of technologies. It could be energy, it could be water, it could be communications, it could be healthcare, it could be food, but it's all infrastructure that permits the continuity of government. So civil society basically can continue because this lifeline has been continuous. Thank you for putting that in the chat. So there's that. I did a quick Googling of the definition of blue sky, and I'm wondering if maybe the person putting in the question was actually asking about black sky conditions. So I'm going to answer it as if it's black sky, because black sky means that there has been a terrible catastrophe, long-term duration catastrophe. And now all that's left for electric infrastructure is your mobile microgrid. Yes, we're designing it for those kinds of events. We're getting more and more interested in a mobile battery storage with microgrid controller that can roll up to a solar array or a distributed wind resource, recharge batteries and take them back to the load, rather than a really big clunky thing with its own solar array. And maybe maybe you can take it anywhere where it's not under black sky and you can actually reconnect something. Yeah, Homeland Security folks talk about black sky and it is really scary. So after the derecho in Ames, the really scary thing for Ames was not the downing of all the power lines or the communication network. It was the loss of pumps for the distribution of water. We were like, I want to say 2 hours away from losing our clean water supply. And if we had one or two of my microgrids, we could have secured the water supply, the pumping to keep the chlorination, all the distribution technology, we could have done that. One really important use case the National Guard has stressed over and over again is a 60 kilowatt water purification microgrid. That's what they want. And Iowa State's not there yet, but that's a really good use case. So it's water, new water. Yeah, I think, oh, I wanted to say one more thing. I know we're running out of time, but the thing that worries me, and this is my challenge to all of you out there, is supposing I get my FEMA grant and I actually get FEMA funding to build a whole bunch of microgrids for small communities all over the state of Iowa, and they're owned by cities. Well, if they're owned by municipal utilities or rural electric cooperatives, if those are the ones who serve the cities who own the microgrids, no problem. But if it's an investor-owned utility that provides power, and now the city has its own microgrid for its critical infrastructure, how does that work regulatorily? How does the rate structure work for that? How do they maximize the benefits to both the city and the utility by having this additional thing that could shave peak or participate in a market? I've looked, and NARUC has, I think it's NARUC or NASEO, has a really good report on all the things you have to think about. And I don't know if any state has actually come up with rules for that. So thank you. That's my question back to you.
No, I think that's really valuable. And I hope that those are the types of peer sharing that we can share through this group and in some of the resources that we're developing. And I know we're getting close to the top of the hour here, but maybe if you both would indulge me for a less than 20-second response on this question, and maybe it's too ambitious, but what advice would you be giving to states that are considering these kind of innovative project designs in 20 seconds or less? We'll start with Armando.
Yeah, no. First of all, thank you for all the support that we have received at the different agencies in California, CPUC, CEC, CARB, and also the local county governments, right? So you just continue embracing this clean energy infrastructure, right? There are a lot of interesting use cases that all together, regulators, operators, technology providers can really come out with really interesting solutions to really tackle the two major issues that we face, right? Decarbonization and reliable energy. So just continue working together and embracing all these new systems. So thank you for the opportunity to talk about
Great.
that.
No, thank you, Armando. Anne and Shelley, 20 seconds or less.
I would say we did use federal funding for this, and not the biggest amount of award we've ever given, but it's more metrics than we get off of any other project. So the metrics off a project like this are really valuable back up to the Department of Energy.
And I would just say that it's all in the use cases. It's the critical, how you define the critical loads, and how good is your data. And if you have a utility that's willing to work with you and give you really good load profile data, everything depends on that. And we had to get our load profile directly from utilities. Nationally, it's pretty general. So we're down to getting utilities to trust us with real life scenarios. So it all depends on the goodness of your data.
Great. Well, I want to take an opportunity and thank the panelists. Really interesting projects you are all involved with, and I'm sure our audience is interested in learning more. So we'd be happy to facilitate those connections. And as always, I want to thank NASEO for this working group partnership we have. And Kelsey, I don't know if we have an announcement about any future things coming up, or we can let people go then.
Yeah, thank you so much to our speakers and attendees, and as always to the Department of Energy for sponsoring this event. And we do have some additional resources coming soon, so be sure to reach out and join the working group and get on all our mailing lists, and we'll share some exciting new publications soon. Thanks again, everyone.
Thank you.
Thank
Bye.
you.
Thanks. Bye-bye.